Classmates, here's a typical problem. We call this a deferred annuity because the annuity doesn't begin today. It begins later into the future. So if we want to know the value of that annuity today, again, as always, we have to account for all payments and all compounding periods. So we discount the annuity of 3 payments, and at this point you have to determine your setting. If you recognize 3 payments and 1, 2, 3 compounding periods, you'll be discounting the annuity to time period 5 initially. Now notice that the amount we want to know is over here on the left relative to the cash flows. So that gives you an indication, a heads up right up at the start, that you want to calculate the present value of an annuity instead of the future value of an annuity. So let's say the interest rate per period is 10%. Excuse me. So in the financial calculator, enter 1,000 payment, 0 FV, 10I, 3N, compute your PV, and on an ending setting, present value of an annuity from your formula sheet. Notice that the same number of compounding periods as payments, 3 payments and 1, 2, 3 compounding periods. That's an ending setting. So that amount is $2486.85 at time period 5. Now we further have to discount that amount back to time period 0. So that amount now being to the right of time period 0 is the future value. Enter 5N, 0 payment, and compute PV. And that's 1544.13. And let's recap at this point. We have accounted for a total of 8 compounding periods, and annuity payments we've accounted for 3. All told, we accounted for 3 annuity payments in the first step in 3 compounding periods, and in the second step we accounted for 5 compounding periods and 0 annuity payments. Now, as I said, I don't like to work problems a couple of different ways in class because it tends to be confusing. So what I'll do at this time is again draw out the timeline. Same problem, and again account for all compounding periods and all payments, but this time we'll use a beginning setting to account for the present value of the annuity, and in that case we want to know the amount of the annuity at time period 6. Because if you look on your formula sheet, present value of an annuity, it accounts for a situation where you want to find the present value of an annuity where you have, in this case, 3 payments and 1 less compounding period, 1, 2. So all you have to do is change your calculator to beginning, and here on the TI-83, that's second begin, change the setting to ending, to beginning, and lock that in by pressing second and quit. Okay, so $1,000 is payment, 0 FE, 10I, again 3N, because N is the number of annuity payments, 1, 2, 3, and not the number of compounding periods with an annuity. With an annuity, N is the number of annuity payments. 3N, compute your PV, and that's 2735.53. Notice that this amount is a little bit higher than this amount here at time 5 because we haven't taken this additional period of interest out. So what we're going to do is now we've got to discount that amount back to time period 0. So that amount is FV. Now 6 is N, 0 payment, compute PV. She'll get the exact same amount, and we do, 1544.13. Now, in terms of this table, I'll recreate it down here for you again. This is, we'll let CP stand for compounding periods and AP stand for annuity payments. Same problem as before, 8 and 3. So, in the first step, we've accounted for 3 annuity payments, but only 2 compounding periods. So that leaves 8 minus 2 is 6 compounding periods to account for in step number 2 in 0 annuity payments. And as you can see, you get the correct answer both ways. And on your test, it doesn't matter how you work these problems. You have a choice. You have the freedom to recognize the problem the way you see it, and you as students will see these problems differently, and that is just fine. But always remember to account for the appropriate number of compounding periods as well as annuity payments. And this concludes our analysis of the present value of a deferred annuity.